We are good to go. So, thank you, everybody. Thanks for bearing with me for the last couple minutes as I was just getting a few things going here. This is a new tool for us, so it's every time we do one, it's a little bit more of a learning experience than the last time. We're trying to make this a regular monthly session, so stay tuned, and you'll be absolutely getting emails from me in the future. Those of you that came onto this maybe via a referral to somebody else, I will absolutely add you to my email list, so we'll be able to send you out when we're doing new content. But we're going to try to do this, if I can, on a monthly basis. So today, again, thank you for joining me. We are going to be covering advanced milling cycles in Sinumerik Operate. I am your host, Chris Pollock. Now, of course, this doesn't want to, there we go. I am your host, Chris Pollock. I'm a dealer support specialist for Siemens. We are a team of gentlemen that are really out here in the trenches a little bit, so to speak, out there supporting really any machine tool distribution that has access to machine tools with Siemens controls. So absolutely, we are here for you as a resource. My contact information is on the slide, so anyone that maybe doesn't know me personally but would like to get my email address specifically and also my telephone number, feel free to record it now. If not, like I said, I'll be sending out a recording of this as well, so you can certainly view the recording and get my contact information. All right, so the online seminar series, this is going to cover content really for our three core controls, the 840 series, 828 series, and the 808 series controls. Some of the content will apply to some controls more than others, so I'll certainly caveat any of these online seminars that we host, specifically with the product it will be covering, because there are some differences in control types, especially when you get between the 808 and the more advanced 828 and 840 controls. We have a couple coming up here. The next one's going to be set up in programming with shop turn, so it's going to be specifically tilted towards shop turn and turning for the 840 and the 828 control. After that, we're actually going to step back and do a little bit more of a basic shop mill class. So this will be especially good for those maybe novice users that want to just get a good overview of setup and programming in strictly the shop mill environment. And then we're even going to do an advanced milling that starts to talk about the relationships or commonality between really 4 different modes within the control of creating or methodizing a part program. You can run Shopmill, programGUIDE, which are the 2 modes we're going to look at today. As well, we have CAD CAM and ISO mode. All right. And let me just respond real quick because the gentleman was having trouble hearing us. All right. So specifically, the content we're going to go through today is going to be both the 828 and 840. So everything we look at and talk to today can be leveraged or utilized on either of these 2 control platforms. It's pretty much going to be identical. From a programming standpoint, you probably wouldn't even really recognize if you were on one or the other. They're very close in commonality or similarity between the 2 control platforms. All right. So just a quick little overview. Advanced milling cycles for Sinumerik Operate. We're going to go through programming a specific part utilizing the upper level commands, what's called our contour profiling cycle, which allows us to mill on the wall of an OD or ID or regular profile. We're then going to do the same thing in an irregular pocket cycle, and we're also going to do the same thing in what we call our spigot cycle, which leaves a boss standing. We're then going to take that shape or that part program, and we're going to methodize it in both Shopmill and in G-code and in programGUIDE. So you're going to get to see how to utilize the exact same cycles in either of the 2 programming environments. So it'll give you not only a good overview of what it takes to create the programs in Shopmill, but then the next step will be to actually create a G-code program and do the exact same advanced functionality in programGUIDE, which are our G-code area. Okay. This is the part program we're going to use, just a simple part I drafted up, just something that kind of allows us to use all 3 cycles on the same part. We're going to roll around and profile the outside of this part, putting on those 2 1-inch corner radiuses in the upper right-hand corner and the lower left-hand corner. We're going to treat this as an open contour, so we're going to assume that maybe the left side of the part is bumped up against a bump stop, or there's a clamp in the way, something's there. We'll never machine that side wall. Then we're going to leave this boss standing, this kind of like C-shaped looking boss that projects up from the part. We'll do that with the spigot cycle. And then we're going to drop in and we're going to do a regular pocket cycle. And in the irregular pocket, we're going to leave that little island standing in the middle. So you're going to get a chance not only to see how to create a pocket of an irregular shape, but a pocket with an island in the middle. So obviously, if there was no island, it would be the same process, just negating out that island feature. First thing we're going to see is we're going to go into Program Manager. I'm not going to do anything from the setup side in this webinar specifically today, but later on, if you do have questions regarding the setup, we can talk about that in the Q&A portion later. We're going to look at how to navigate over to Program Manager, kind of quickly go through the layout of Program Manager, and then how to create a program, how to maybe create a directory, and then initially create either a Shopmill or G-code program. We'll do Shopmill first, and then we're going to go and do programGUIDE second. So with that being said, we are going to go into first doing a Shopmill program. In Shopmill, you're going to get a chance to see how to create the header, which would be the initial block form that defines the solid object, as well as a bunch of modal commands that will get set up through the program. You're going to get to see how the event editor works, how I start to create data and put it into a part program. We're going to go into these cycles, show you all the conversational fields within the cycle, and then we're going to go in and start creating these regular shapes through our contour editor, which is our drawing mode right into the control. We get a chance to simulate. We'll simulate the job using different orientations of simulation, maybe putting wireframe on or off, and you'll see some different features within simulation mode. If we have a chance, maybe we'll look at some of the advanced functions within simulation, like cut mode, your full tool animation. You'll get to see all that. So with that being said, we are going to segue to the interactive live demonstration portion of this event. If questions come up during the process, by all means, you can shoot them out. I am kind of monitoring and running this whole thing on my own, so it can be a little bit of a challenge. So if I don't see it, hopefully I'll see it when we get a chance to stop a little later. All right, so with that being said, just give me a second here to initiate our simulator. So what I'm loading right now is I'm loading what's called Sinutrain, and Sinutrain is the software that we use to emulate machine tools. So this is a software that absolutely can be purchased from us, as well. It can be downloaded for a 60-day trial, absolutely free. I wanted to just bring up a little PDF of the shape as we go, so you can keep that in the corner of the screen there. So hopefully as I'm going, I'll refer to it so we don't go too far ahead and you're not quite sure you understand exactly where I'm getting the numbers I'm getting from. Okay, so again, this will be the part that we're going to program. So first step was to go over to Program Manager. Whenever creating a new program, I have to get into our program area where we save all of our part programs. So you're going to select the hard key right here called Program Manager. It's up where we have our external hard keys. The display you're seeing here, everything in gray would represent a machine panel. Certainly then everything in relation to the screen would be software options or software screens or soft buttons. So we have horizontal soft keys, vertical soft keys, and then everything outside will be hard keys. You'll find in your specific machine tool, the panel layout may change around. We have all kinds of different configurations of panel. But for the most part, the terminology of the buttons stays the same unless a builder did something custom. So in here, again, I'm going to select Program Manager, and it's going to be to put me to the Program Manager area. What you see when you first come in, and I'll just minimize these different folders, is you have three primary program areas where you can store programs. You have the part program area, which allows you to simply put MPF files in. MPF stands for main program file, and that would be a part program, either G-code or conversational. They both would have MPF extensions. You could create subprograms and put them in the subprogram file. They would have an SPF extension. Or you can create folders, and then inside those subfolders, you can have your part programs. So I can really do either or. So like, let's say for argument's sake, I wanted to create a little folder to put these couple programs we're going to create in today in. I would strictly be down in the workpiece area, select new, and immediately highlight to the directory option. So now I can come in and maybe say that we're going to create a folder called samples. Type in the folder name, select enter. It does immediately ask me if I want to create a part program of that same name. I do not want to, so I'm just going to hit cancel. And it simply creates a folder for me here. As well, you can create programs and manage programs from outside sources. You may have a local drive, which would be extended memory on your machine tool that represents with the local drive setting. USB would be your full USB support. Then you can actually have external devices as well. I happen to have created a second local drive that maps a portion on my hard drive, but this could be absolutely a network drive, other USB devices if I wanted to do that. You can get pretty elaborate in customizing the interface. For this case, we're just going to come into samples and we're going to create our first program. Now, when I go to create a program, I'm hitting new again, and now I want to pay attention to my Shopmill or my programGUIDE options here. So if I select Shopmill or programGUIDE, that'll initiate the type of program I'm creating. So we're going to do a Shopmill program. So select Shopmill and give it a name. So I'm going to call this, let's say, SM for Shopmill. When I'm creating names, I can use letters, numbers, or underscores, any combination thereof. So Shopmill sample 1, we'll say. So you type in your name. Now we're going to go and we're going to select the OK key, and that will initiate it creating a new part program. Okay. So when you first come in and you have this, what we call the header page, you're going to ask a few basic questions. Question 1 was going to be, what work coordinate do I want to use for this specific job? It's right now defaulted to G54. How many work coordinates do we have? We support up to 99. This one only was commissioned up to 519. It's really more up to the builder and how many he's going to normally give you as a base machine. And then I have my blank type. Now the blank type, which in this case I see we have cylinders. I can do pipes. I can do hex stock of some type. We can do a basic block, or I can do a block centered. And all of these are really for graphics, for system graphics. It's not really going to have much bearing at all on the actual part program. A lot of guys would get a little caught up on this, thinking that, oh, if I can't get the exact blank, it doesn't exactly match the part shape that I'm really machining from, is this going to be able to cut? Absolutely. You might know where it's not cutting on yours, where it thinks it's taking a heavier cut on mine. We just want to have something for simulation purposes. Now, on this part, I did something a little unique just to show you how you can adapt this to multiple configurations. I'm treating my y-axis center line to be y0, but I'm going to treat the left edge of the part here, if you look at the PDF, the left edge of the part, to be my x0. So all of my stock is going to be 6 inches over in the x, maybe a little bit more, and then my y is going to have some plus stock and some minus stock. So first position would be x0, that's that end. I did mention that we were going to theoretically think that there's a bump stop or something there, so we're not going to cut anything. Well, so that would be absolutely 0. I'm giving it -3 inches in the y. It finishes at 5.750. Might be a little hard for you guys to see, so I'm just giving it a little bit extra meat here. Same thing in my x. We'll finish at 6, so I'm telling it, hey, the blank's a little bit longer than it really is, so I'll give it 1/8 of an inch. I'm giving it a +3 inches. Remember, it's symmetrical, so we'll just give it plus. Top of my part. If I wanted to face it off, I'd probably give a little plus stock. I'm going to say that the top of the part's fine, so we're going to leave that at 0, and we give it an overall thickness. This could be thicker than the part, obviously, if I knew I was clamping and I wanted a representation of that. Here, I'm just giving it the overall, which is 1 inch. Next question is my orientation of my tool. Standard would be G17, but I certainly have the option of inverting the tool in any of my planes. This works out very well when I'm using right angle heads on a 3-axis configuration, because it allows you to really take all of your can cycles and they'll all run in any of these orientations. So if you're drilling a hole, running a pocket, whatever, in either a G17, G18, or G19 plane, our system can run all the cant cycles in those planes. Retract is where I'm going to go when I'm done with any given cycle. So I'm moving up 2 inches here. Safety distance is how close I want to get to the part before I start feeding. So she's going to wrap it down within 100 thou. This is an incremental value of any surface, and then begin feeding from there. At this point, I define whether I want a climb mill or conventional mill. Climb milling is going to be down cut. Conventional milling would be up cut. So we're going to climb mill, the whole part. And then if I was drilling or doing something like that, I have the ability of either doing an optimized retract or always retracting back to my retraction plane, which in this case is 2 inches. I'm going to leave it optimized. Now you'll find a lot of these settings will carry through because we don't have, or we don't typically like to have predefined values in the fields. We like all the values to be what we consider user-definable variables. So as you start to put in and adjust these settings to things that you like to do, maybe you like a 2.5-inch retract. Next time you write a program, it will be there. So from here, I'm going to accept or save my first event. I hit accept or save, and there's my first line, or my header. From now on, I'm going to go through my horizontal soft keys to pick the cycles I want to machine. I'll use my vertical soft keys for maybe added functionality in the cycles and kind of navigate through the control this way. So in previous webinars, or certainly in the webinar that's going to be coming up, which is strictly the shop mill milling setup and operation, we're going to go through in detail drilling and the basic milling cycles. For this one being an advanced class, we have to obviously assume that you guys know how to use some of these. But what we're doing is we're going to concentrate on our contour milling cycles. So under contour mill is the 3 main cycles we're going to cover in this webinar. We're going to go into path milling. Path milling allows us to handle profiles. We're going to go into pocketing, allowing us to handle a regular pocket. We're going to go into the spigot cycle, allowing me to handle the boss that's standing up from the part. So first thing we're going to do is I'm going to go in and I need to create some shape, some contour that I'm going to cut. So what we're going to do is we're going to start with machining this outside profile, machining this outside shape. So with that being said, the first thing I need to do before I can leverage any of these cycles is I got to draw something. So we're going to go into new contour. New contour allows me the ability of naming the contour. So I'm going to call this contour 1 for my first contour, let's say. And that's going to be the outside contour. Maybe I could put outside. Well, really anything you want. This is just simply for your own reference. Select accept. Now it comes in and you're in the contour editor mode. So this allows us to actually start drawing the shape. So what I'm going to do is I'm going to start in the upper left-hand corner, which is really half of my 5.75 or my 5 3/4 inch value, because remember center is 0, and it's going to start in an X of 0. So come down, X of 0 is where I'm starting. Now, right inside the fields, if I want to, I can do basic mathematical equations. So I can put 5.75 divided by 2, and it gives me my 2.875. As well, you'll see later, if you use the equal sign, I can even bring up a full calculator to do some basic math. And we'll show you that a little bit more later. Type in your value, select accept, and it stores this first position. Once you've stored the first position, you're now going to use these vertical soft keys to describe the shape. So is your first move going to be a horizontal move, moving in the X? Is your first move going to be a vertical move? Is it going to be a 2-axis move, some kind of angle? Is it going to be an arc move? So in this case, we're just going to do a very simple horizontal move, hitting my X horizontal button, and I'm telling it to go to a known location, which I happen to know is 6 inches over in the X. Now, when I get there, because I'm actually telling it to go to really the intersection point of 2 straight lines. When I get there, I can tell it to automatically create my 1-inch radius for me by telling it that the transition to the next element will be 1 inch. If you can't position to the intersection of the 2 lines, then you would have had to generate this with an arc, and I would have to stop at the start of the arc. We're going to move down. In this case, I'm moving down, and you can use negatives in here if you're going to do your math. 5.750 divided by 2, there's my 2.875. I'm going to do another radius because I have a lower corner radius of 1 inch. We start to see it's drawing for me. So if I put in a bad number, I should be able to catch it right away. Moving back, brings it back to 0, accept it. Now I have my first shape. Now in this case, I do not want to return to my start point. Remember, I said there's going to be something in the way here, some kind of a bump style. So if I was to move back, it's going to treat that like I'm machining that portion. So you're really drawing the surfaces that you are going to machine. Now you'll notice, as I created these, on the left side, it created these little icons. So if I use the blue arrows, I can move my cursor up and down, showing each of these icons. So if I had gotten, maybe I typed in the radius wrong. I put some small value here. Maybe I typed 0.1 as opposed to 1 inch. Well, I would see that immediately. You can use these icons to modify. I'm hitting the blue arrow over to get down to the area where I'm going to make the change. I can insert. Maybe I missed an element, so I needed to insert. I can delete an element. I wanted to delete something there. And it's always going to insert or delete. It's inserting below the one that's highlighted, or it's deleting whatever one's highlighted. So once I get the shape the way I want it, now I'm simply going to hit the accept key. Accept now comes out, shows me my contour. Now I can associate that contour with my physical cycle. So my first cycle is going to be path milling. And this is going to be very similar to those of you that are used to doing like milling cycles in the control. So you're really just going to fill out the events from there. So first question is my tool. So I'll hit the select tool key. Once I hit select tool, I can go down or up and see my tool table. This is a representation of my tool table. If I didn't see the tool I needed here, I could hit tool list again, go all the way back to my tool table, maybe create a new tool. In this case, we're going to use a 3/4 ML. So I'm highlighting it. I select to program, and that would fill out this tool. As I move down, I have the ability of programming either feed per tooth, or I can program inches per minute, either or. And as you type in a value, like let's say I was putting 10 thou per tooth, and I toggle this back, it will show me the calculated feed rate of the two. Same thing with constant surface speed or RPM. Both can be defined. Am I roughing, or am I finishing, or maybe even putting a chamfer on the shape? Those would be the three primary operations I can do. Here I'm going to rough it out. Forward or backwards? Do I want to follow the direction I drew the shape in, or go the opposite direction? So in this case, I'm going to go forwards. Cutter comp. Am I cutter comp left? Cutter comp right? Do I want to not use cutter comp at all? Maybe this is something like an O-ring groove. So I'm going to use cutter comp left. I know I'm on the left because as I'm following the path that I drew this in, my cutter's physically on the left side of the part at all times. Also, if you're on the outside of a part and you're climb milling, you have to be in cutter comp left. Same thing if I was on the inside of the part climb milling, I would be going the opposite direction, but I would always be in cutter comp left. You can't be in cutter comp right and climb mill. Okay, top of my part is 0. Overall thickness is 1 inch. I know that from my print. How much do I want to take per pass in Z? So I'm going to take this in 2 cuts. Do I want to leave material for a finish cut? This portion of it, I'm not going to worry about a finish. I'm going to bring it right to size. How do I want to get onto the part? Well, here I got some options. I can lead on straight. I could do a 90-degree arc. I could do a 180-degree arc. Vertical will only be used if I'm not using cutter comp. So this way it will drop down in center line on the part, so I don't have any lead in or lead out. Like if it was an O-ring groove, I certainly wouldn't want to lead it. Here I'm just going to do a straight move in of some distance, some feed rate. How do I want to get off? In the same scenario, I don't have to come in and go off the same way I came in. So I can do straights, quarter circles, semicircles. I'm just going to do a straight move out of some length. Now this last one, this is very important, especially when I have a condition like we're talking about right now. This is what do I do between passes. So if I did no retract, the machine's going to get to this lower corner, this lower left-hand corner of the part, and then wrap it straight across the back. It would make sure it cleared it because it's going to be a ½ inch away. But if I had a stop there, I would have just hit the stop. So I could jump all the way up to my traction plane, which was I think 2½ inches or 2 inches above. I could move just up to the top of the part plus my safety distance of 100 thou. or just back up the safety distance. So if it was a bump stop and the stop was just below the top of the surface, I could absolutely just go to my Z0 plus my safety between each pass. And when I graphically simulate this, you'll see exactly what I'm talking about. I say accept to accept the physical cycle. Now I have actually enough data that this could be a legitimate part. So if I jump over to simulation, we can see if I got any typos or it's starting to look like a part. I can look at it in a top view. I can look at it in 3D. I can do with my expanded double arrow button right here, I can get to my show path. Show path's nice because now I can start to see what was going on here. So this was the end retract. I got back around that back side. She jumped up to the safety distance, over and back down. So as you play around with this, you can see, you know, if I left it where I was before, it would have gone straight over. So it gives you a lot of ability to see the cutter path that the machine's really going to take. So I'm going to leave the path on. We're going to jump out of here. I can come out of simulation either by re-hitting the simulation button or hitting the edit button, and that will put me back to where I was at. All right, so we're out. We profiled our part. Now we're going to come in and we're going to machine this boss, or what we call a spigot. So we're leaving this feature standing. So if you can kind of see on the lower view of this print, that little boss is standing up 3/8 of an inch. So the surface down here is really 3/8 down from Z0. Z0 is still the top of this part. So what I'm going to do is a couple of things have to happen when I use the boss cycle. Not only do I need to draw this boss, but first I need to draw the actual stock that I'm machining from. It has to know where it's starting and where it's going to end. And it always works from the biggest to the smallest. So that's the order of operations when I draw the shapes. So it's very critical that I start with the outside shape and work the inside shape. So in this case, the contour that I just drew is really what's going to become the stock for the next feature, because I'm going to be machining from this contour to this boss. So I'm going to reuse the contour. And I'm going to reuse it by selecting the edit key, hitting copy while I'm highlighting the contour. I'm now going to move my highlight down to path mill because it's going to paste it or insert it just below. And it now gives me the ability of renaming the cycle. Now, you do want to rename it because you will have to make a change. If you don't rename it, the shapes will become linked, and any change you do to one will reflect another. So in this case, I'm going to call this stock. Type in the name, select accept, it now put it in. Now, I did mention I need to change it. Well, once it becomes stock, it's strictly using this shape to represent what it's machining from. So stock historically can't be an open contour. So I'm going to move my highlight down to my last line. If you hit your little double arrow here, we have an option for close contour, or I could have just given it a line back up to the top point, but this is the cheater method. That puts me back to the start point that I was at. So now all I have to simply do is hit accept, and now I have the stock for this spigot cycle. So once the stock's drawn, now you can draw your spigot or your boss. So we're going to go back to Contour Mill. I'm going to go to New Contour because I want to draw a new contour. I'm going to take the name of it. So I'm going to call this, and I'm just going to call it Boss. So type the name of the contour, and now we're going to start drawing. So in this case, I'll probably start at the lower left-hand corner, which is 3/4 of an inch over, and it's down off center line by 2 inches. And then I'll walk around the part. And I want to walk around in a clockwise direction because this is still an outside feature. So I want to still climb mill this part. All right. So X is going to be 750. Y is going to be -2. That should be this lower corner. I'm now moving up the shape to a Y of +2. If you look at the print, it's kind of hard to see, but all smaller radiuses are 1/4 inch typical. So unless they call out something different, we're going to do 1/4 inch. So in this case, this is going to be a 1/4 inch radius. That's my first vertical move up. Now I'm going to move over in my X. I'm moving over to a position of 2.5 inches. I see that right here, dimension at 2.5. We got a simple little radius, 1/4 inch. Accept it. Start drawing. Coming down, this happens to be going to a y total of 2, so that would be half that. I'm going to a y of positive 1 with a 1/4 inch radius. Accept it. I'm now moving back. I'm moving back to a 1.750 dimension. I see right here. And we have another radius. Coming on down. I'm coming down to -1. Same radius. As well, transitions can be radiuses or chamfers. Everything I happen to do in this example is just radiuses. We're going to pull back out to the 2.5, 2.5. All right. Radius can be 1/4 inch. We're going to come down. I'm coming down to a -2. Now, I can absolutely use the close contour function if I wanted to now, but I'm going to have to go into it anyway to put this last radius because I have a radius in the start corner. So here I'm just going to do a line over to the 0.750 where I started from, tell it my radius, and there we go. We have our drawn shape. Looks like the print. Looks like we're pretty good. So at this point, I'm simply going to accept the profile. And I see how the two profiles link together right here. They're now associated, and they're just waiting for me to give it some kind of a cycle. So what I'm going to do now is I'm going to go to the spigot cycle. I select spigot, give it the tool. I'm using the same tool. Some feeds, some speeds, top of my part. How deep is the pocket going to be, or in this case, the boss, 3/8. What is my step over, my radial engagement? You can hit the select key right here and be a linear distance or a percentage of the cutter. We're going to use a percentage of the cutter. Depth per pass, I'm going to take this in a couple shots, 1/4 inch. And do I want to leave any material for a finish cut? So let's say I wanted to leave a little bit of material for a finish pass. I could absolutely do that, or I can bring it right to size. I'm going to bring it to size. I hit accept. Now, what did this just do? Well, it certainly came in and gave us our spigot. So here you can see how it's machining outside of the part. It's going to wrap it, trying to optimize its cutter path, and leave this boss standing for me. It's doing it in 2 cuts. So here we go, coming across, doing it in 2 cuts. Okay. Now, you see in here, we obviously have a much greater radius in these 2 corners because of the radius of my tool. So now this would be an issue. I have to figure out some way of getting that material out. So in this case, I'm going to show you how to use our residual material function to clean out those 2 corners. So back in this program, I have the option under Contour Mill to go into Spigot Residual Material. And what that's going to do is that lets me pick another tool. So I'm going to use a 1/4 inch tool, give it some feed rates and speeds, my radial engagement, do 50% of the cutter, depth per pass, and it's going to link them all together. So now it's going to say, okay, well, I'm going to look back, figure out where the 3/4 inch tool couldn't physically machine, and just go back and machine those couple areas. So come around, we're going to machine up, leaving the boss, and then you're going to see the tool going to come in and pick those 2 areas. All right, so it picks out the 2 corners, leaving a 1/4 inch radius in both of these 2 corners. Look at it in 3D. We could even zoom in here a little bit, and you can see. It will, when you let it fully refresh, give you a slight like witness line, which would be where the end mill would be touching the other surface. So if we give it a second, you can see like the little lead in. That's just your normal transition. It's not actually digging the surface. Okay. So at this point, now it's time to go and machine our irregular pocket. So we're going to use the pocket cycle, and we're also going to leave a boss. So in this scenario, I'm going to go back over to Contour Mill. I'm going to go to New Contour, and I'm now going to name the pocket. So I'm going to call this my pocket. And we're going to draw up this pocket. So it's going to be this whole area right here. So with this being said, I want to come over, and I'm going to probably start in this lower left-hand corner. I'm going to go around the opposite direction because I want to climb that wall, and we're going to roll around that shape. So that corner I happen to know is an x of 2.5, and it's down at y of negative 4.750 divided by 2. All right, so that's my lower corner. We move over to 5.5. Now this corner radius, if you look at the print, is actually a 1/2 inch, so I'm going to put that in. I'm going to move up. We're moving up to the 4.750 with another 1/2 inch radius. We're going to come on back to my 2.5, and here we're going to have a 1/4 inch radius. I'm going to pull down. I'm going to pull down to an x of, or y of 1, shall I say. And this is where the pocket and the boss kind of touch. So you'll see where there's a little bit of tangency between the two. So here I'm coming back into that surface of 1.750, my radius. I'm going to pull down to -1, my radius. Come out to our 2.5. And now we're going to move down to my final, oops, typo. And we'll do our final radius. So at this point, I have my feature drawn. So I'm first going to draw, just like I did with the spigot cycle, I'm going to draw the outside boundary, the largest portion of this. If this was just the pocket, I would be done. I could immediately just go in and select pocket. But here we have a little feature standing, a little boss, so I wanted to show you that real quick. So now I'm going to, or shall I say an island. So now I'm going to go and create another contour. I'm going to call it my island. Island. Oops, excuse me. So now I'm going to draw this shape. So in this case, this shows you a little bit of our trig help functionality. There's some data physically missing on this part shape. I know my width, I know my radius, but I don't know where these straight lines intersect these two arcs. So you're going to get a chance to kind of see a little bit of that. So first thing I know this back wall, if I was to do the math, if I was to take half of my 1 1/4 and subtract it from my 4, I know this wall is sitting at 3.375 and at y of 0. So I'm starting just dead center of the wall. It's a known position I can figure out pretty quickly. So I'm going to hit accept. So my first move, if I was going to mill clockwise around this shape, would be an X or a Y move straight up. So that's what I'm going to do. Now I don't know where this Y move ends, so I'm going to leave it blank. But I do know the direction I'm going in. So I'm going to tell it I'm moving straight up 90 degrees. So this gives me an infinite line starting at this position of 3.375 and Y of 0 straight up. Now I got to sweep this arc. And I want to show you this because there's a lot of math going on at this point. So you got to sometimes be careful how you input data. So right now, if I type in my radius and I start to put, my known data, we always have a tendency to want to work from the top down, and that's normally how I would do it myself. So I know that this other edge is 4.625, right? Because I know center line and I know this half distance. So I certainly could put that 4.625. I don't know my y, but I know that my x is going to be 4 inches over. Well, see, this system automatically filled out my y for me. It's trying to calculate. That's the whole beauty of how this trig help works. It's trying to compute based on the numbers you gave me. Unfortunately, in this scenario, it's computing the wrong center because I need to give it the y location first. So if I was to accept this circle, it's not the correct circle. It's not the correct arc I need. I need an arc that's a partial arc somewhere up here. So don't be surprised if you have to, if you're not getting the result you're looking for, if you have to change the order that you put some of this information in. So like if I tell it I have an absolute position of y0 here, and then I put my 4, and all of a sudden I start to see the arc that I'm looking for. Now in this example, there's always still 2 potential arcs, your obtuse or acute arc angle between the two. So you want the one that's orange. So I don't know if it's if you can kind of really tell from the screen. But right now, the smaller of the two arcs is orange. If I hit dialog select, the bigger one. So I'm going to pick between the two arcs, pick in this case the smaller arc, and hit dialog accept. Once it's all filled out, it filled out all the other variables for me. I hit accept. I see that arc. Now I'm going to do a line down, and I'm going to keep going with the trig help theme. I'm not going to use the numbers it just calculated for me. So I know my next move comes down to 70. I'm moving down. I'm going to do another arc. In this case, the arc is a clockwise arc, a radius of 1 inch. Again, I know my x end, I know my y is 0, and I know my x is 4. So as long as I gave them in that order, I would have ran into the same problem I ran into before if I didn't. So don't be worried, don't be afraid of trying to change around the order a little bit. You're not getting the result you want. Here I get the appropriate result. I accept it. I accept that arc again, and this is a good example where I can choose the closed contour, gets me back to my starting point. And now we have this feature created with data that I had no idea about. So once you have the island drawn, I hit accept. The two features associate together. Now we're simply going to go into the pocket routine. We're going to pick our first tool. In this case, it's going to be 3/4 inch end mill because we're going to rough it down. That's what the single diamond always represents. Now, in this case, the pocket starts down at 3/8 because remember, I already cleared off all that material. So I would tell it my Z0 is -3/8 down. And then from here, the overall pocket depth, which dimensionally I'm shown on the part to be another 3/8 down from that surface. So I could have either done an incremental value 3/8 or an absolute of 750. DXY will be my radial engagement again. So as I'm spiraling out, I'm going to use 50% of the cutter diameter. Depth per pass. Do I want to come back and leave any material for finish cut? So I'm going to leave a little bit on my wall. And how do I want to enter my part? I can enter with a helix. I can enter straight down, assuming I have a center cutting end mill, or I can come in at an angle. Another nice feature is the starting point. Automatic, the system will figure out its best possible starting scenario. Manual, I can give it a coordinate. So if you had a hole here and you wanted to drop into a hole, you could tell it that. And same scenario like before, my lift mode between passes, what do I want to do? So you fill out the page, you hit accept. Now if I go simulate it, we'll see it come in and machine this pocket. We'll just go quickly to a top view. And this should machine my pocket with the boss standing. Okay, so I have the same problem I had before. I left some material. In fact, if you can look, you can even see a little ridge because I didn't quite clean it up. I left material. So it roughed out everything it could with that tool, but left us a little bit of material. So just like we saw earlier, I absolutely have the ability of going back to my contour and using residual material for pocketing. So here, I'm going to select a new tool, in this case, 1/4 inch end mill again. So very similar parameters to like I used before. I hit accept, and this would go in and pocket out or clear out those little corners. And for me, I'm going to just come back in and do one final finish pass with the 1/4 inch tool. So I'm going to go back to my pocketing cycle, make sure I select the 1/4 inch tool, 1/4 inch end mill right there. Fill up my feeds and speeds, tell it I'm going to be finishing. Am I finishing on the wall or just the base? I'm going to finish it on the base. I want to make sure I zero out my X and Y, top to bottom, and I hit accept. At this point, we can do one final simulation, and this would be that program done conversationally. So let's just jump back to a top view, and we can see it machine the whole shape. Looks like we're going to run a little longer than an hour today. It's a lot of content to get through. If anybody has to jump off, I'm going to keep going. So if anybody has to jump off, I absolutely understand. And again, I'll send out the recording. So for some reason, I'm going to miss you for the tail end of this. We will you'll get a chance to review it in the recording if need be. Okay, so at this point, what I'd like to do is I want to go back. Oops, bear with me a sec. I want to come back to the PowerPoint. And this is a little clumsy. All right. So everybody has the PowerPoint. And now I'm just going to show you how to do this exact same feature, but in G-code. It won't take quite as long because we'll be able to reuse some of the data that we saw earlier. All right. So on programGUIDE, you're going to get a chance to see the programGUIDE interface, kind of how the whole structure works. You're going to get a chance to see the cycle support. In our programGUIDE, we actually have like a hybrid conversational built into it. So when you go into complex cycles, you actually get a conversational field that comes up. And it looks very, very similar to the Shopmill that you were just seeing. As well, you're going to get a chance to see how the features or the irregular shapes are created. It's the same contour editor. So that's where I'm saying I'm going to draw one of them. You get a chance to see how one of them implements, and then I'm going to get to reuse the other contours. So you're not going to have to see me, you don't have to sit and kind of wait for me to draw all these different contours up. But it's nice if you get a chance to see it. You implement them a little bit differently than you do in G-code, and or conversational in Shopmill. And there's certainly some advantages you're going to get in G-code as far as your order operations. So that's something that we'll look at here in a second. We'll still show you the same simulation, so you get a chance to see how programGUIDE supports the exact same way for simulation purposes as well as Shopmill. And we'll take a look at that live. And then if we have time, we'll maybe take a look at running some stuff in auto. All right. So with that being said, we want to bring up our simulator and our print again. So now in this point of the seminar, we're going to go back to Program Manager because I'm now going to create a brand new program. It's going to be a G-code-based programGUIDE program. So we're going to select New again in Program Manager. I'm now going to select programGUIDE, and we're going to physically type in the name of the programGUIDE. So I'm going to say it's a programGUIDE sample 1. All right. So give it my name. Now, the one thing you immediately see right off the bat is there's no header screen. There is no header screen or event in G-code. So what we'll do is we'll do those commands that would normally be built into the header as discrete functions. So with that being said, one of the first things that we're all used to in Shopmill is the event or the section where we just find the blank for the graphics. So how it knew that it was building basically a 6x6 block to machine from. So it's the same thing over here. I just have to do it as an individual function or cycle. So if you select the various field or various button right here on my vertical soft keys, I'm going to see an option in the upper right-hand corner called blank. And blank gives me all the same options I saw in Shopmill or I'm used to in Shopmill. Cylinders, pipes, basic block with the center, block like I did just now, which we'll do again, hex stock. It's all right here. So in this case, the variables, they all spell out the same like I did before. So I'm saying that the left side is x0, top corner is 3, right side, we'll give it a little bit more material. We'll give it 6 1/8, so it matches the last one. Down 3, overall part thickness is 1 inch. So you fill out the event or the cycle, accept it, and it builds it as a physical cycle. So that's where we get this workpiece function. From there, I can start going on and continuing with my part program. So some of the stuff that maybe it does automatically for me makes it a little simpler. I do have to do some discrete commands. So I may want to give it a G90 to tell it I'm in an absolute mode. I may want to give it a G54 to tell it I'm using work coordinate number 1. I may want to tell the system a G700 to make sure it's in inch mode. And I may want to give it a G17 to define a plane of XY. That would be a very typical header line you would see in a G-code program. The next step that I have to do is you're going to notice when we go into the cycles, we don't have commands for the tool changes. You will do tool changes independent of the cycles in G-code. So in here, if you simply hit the edit button, we get a select tool field that looks very, very similar to the way I see it in conversational. So it gives me the list. I can hit tool list, do all the way back to the tool table, or highlight the tool I want. In this case, I want my 3/4 end mill. But now it's going to build it how it looks in G-code. So whenever I'm calling up a named tool, it's always T equals, and in quotation, the name of the tool. If the tool was a number, like number 1, number 2, then I can just simply write T1 or T2. I'm going to put a D for my cutting edge. We can support up to 9 offsets or 9 cutting edge for each tool, and they're called by Ds. So I'm going to tell I'm just using offset number 1, D1, for that tool. I want to tell it to physically do the tool change with an M6 statement. From there, I may want to start my spindle, so I'll give it an S command. Maybe we'll run the spindle at 2500 RPM, and we'll tell it to turn on with an M3 statement. I do not need the leading 0. I just, out of habit, I put it myself. How am I machining? Am I running in feed per minute, feed per rev? I definitely have some options here. I'm going to do feed per minute, so that's a G94. And I'm going to say that I'm just running 50 inches a minute. Okay, now this is where we start to see some differences. You know, I'm used to, at this point, basically going right to a contour, calling the contour up, and associating our cycle. In G-code, it works a little bit differently. First of all, the contours don't necessarily have to be inside the program. They could be sitting outside the program. But what you'll also find is the contours exist below your M30, your end of program statement. So what I'm going to do is I'm going to put a couple blank lines there for a second because I'll be going back. And now I'm going to give it an M30 end of program. So at this point, I'm going to go back to Contour Mill. And you're going to see it looks almost identical to the way it looks over in Shopmill. And I do have a contour option. But what it'll do is it'll create a little G-code result of the contour down here. So I'm going to select contour with my highlight just below my M30. I get 2 options. You're going to see how to use call contour in a minute. But we're just going to do new contour. So select new contour. Type in a name. So I'm just going to call this contour 1, we'll say. Use the same name we used before. Doesn't matter. Select accept. And now I'm drawing. And the drawing works exactly the same way you just saw. So, you know, we said that we're starting at 0, and we're starting at 5.650, level 2. And I rolled around my part. So I went over to 6, had a 1-inch radius. We came down to my minus 2, and D divided by 2. Okay. We got my 1-inch radius right here. We're going to move on back to my X of 0. So it looks just the same way we just drew it before. It's the same function, same key strikes, everything you just saw. Here's where the difference comes in. Once I hit accept, I see this little contour right here. These are all the geometrical points associated with that contour. So instead of just seeing the line that says contour and a right arrow, I'm always going to see these contours below. At any point, if you hit your blue arrow over key, you can open it up, make your editing changes the same as we did before. I would just see that the editing change would come up down under here. So we'll build all the contours down there, but first I'm just going to show you the rest of the structure as to how to use the contour. So if we come back up and we go just below a G94, when it's time to use a contour, we actually call up the contour with the contour call contour or contour call button right here. So if you are out doing something else and you need to come back, you always got to go back into contour and now use the call contour function. And this allows me to tell it when I want to use the contour. Contour 1, so you just got to make sure you get the name typed properly. And so what it does is it builds this cycle 62. And cycle 62 is saying, hey, I don't know what you're doing next, but I now have contour 1 in memory ready to do something with it. So at this point, the next statement in my program is going to be a simple path mill. Couple differences that you might see. G17 we didn't traditionally have to do in Shopmill. You do here because, again, there's no header page. The retracts, the safety distance, those couple things that we're used to being in the header page, we just added to the cycles. But my feed rate, roughing, forward, all the other definitions, everything you see here is identical to what I just described in Shopmill. So that's certainly why this portion of the program will go a little bit quicker. So I fill out the page, same questions I had before, I hit accept, and now it has the cycle here. So if you were to simulate just this, we would look just like we saw before. We would just machine around that shape. So now it's time to put the rest of the mechanism in. So first thing I would normally do if I was writing this from scratch is I would probably just go and start creating all of my contours. Certainly I'm not going to make you guys have to watch me create all these contours. But what is kind of neat is I have the ability of dragging and dropping things between other programs with my cut, copy, paste functionality. And I can even go as far as if I'm on the edit key and I hit the double arrow to change my vertical soft keys, I can go as far as opening up an additional program. So in this case, I'm going to cheat a little bit. I'm going to go open up the program we just wrote. So it was under workpieces, it was under samples, and it was my Shopmill program. So there's the Shopmill program we just created. So I'm going to want to get my stock contour, my boss contour, and I'm going to want to get my pocket and my island contour. So you can actually drag and drop contours between G-code and conversational. So simply highlight the one you want, hit copy. I can move over here, hit paste. Now, in Sinumerik Train, it's really quite nice and easy. I can bounce between the two screens with my mouse. On the physical machine, you're going to use a button. It's called Next Window right here, and that will bounce you between the two screens. So on the machine, you do have to use the Next Window button if you don't have a mouse. So we're going to highlight the contour boss, right? Because I already brought over the stock, so now I want my boss. I'm going to copy it. We're going to move back over. I'm putting blank lines between each one. I find for myself, it just makes it a little easier to read down the road. If I have them all together, it looks a little jumbled. It's harder to kind of differentiate where one contour starts and one stops. But it doesn't matter. You don't need the lines if you don't want to. I'm going to grab the pocket. So we're going to copy that one, bring it over, paste it. And then I'm going to my last one. I'm going to grab the island. Certainly everything I showed you on the island would hold true here as well. The way the trig help function works, it's identical. It's the same mechanism that you're launching. Paste it. So now, below our M30, we have all of our additional contours. Everything's going to be sitting down below M30. So at this point, we're going to start moving forward with our program. So go back to the window that in this case I want to close. So I want to be active in my Shopmill program. I can hit the double arrow over. I get close option. That closes the other program. So now I can continue on. So I'm going to give myself a little line space there. So now the next operation I did before was I machined the spigot cycle or the boss cycle. So we had to have two contours drawn in consecutive order, the stock and then the boss, right? Well, it's going to be the same concept here, except I'm doing that strictly with the call contour function, which is cycle 62. So I'm going to call up my stock first, and then I'm going to call up my boss. All right. And now we're going to go into the spigot cycle. Now, when you get to spigots and pockets, it asks you for this program name. It's really generating a program in the back end. The name you give it doesn't matter. I actually use the same name each time to let it write over itself. I usually just give it the number 1, but you do have to fill something out or it won't let you go any further. In the cycle, you do tell it your playing direction, stage G17, your retraction, your safety distance, again, because remember, we don't have the header cycle. But then everything else, feeds, depth per pass, top, bottom, step over, it's identical to everything we saw in the Shopmill portion of the demo. So I can strictly hit accept. So this would come in and this would rough it out with the 3/4 inch tool. Now, what's nice about this is I'm actually going to alleviate one additional tool change. Because the way we wrote the program before, she would rough out the boss, switch to the 1/4 inch tool, pick the residual material of those two corners and then jump back to the three corners tool when I go to rough out the pocket. So you do have a little more flexibility when it comes to programGUIDE. I can do all of my roughing operations. So now I can come down and do my contour. I can call up my island and my pocket. This is why I like to use common names, so I don't have to go running down remembering what I put all the time. Island. And we're going to go back over to the pocket cycle. See how it asked me to give it a program name again. I just use number 1. Retract, we were retracting the 2. Am I roughing or am I finishing? Maybe in this case I want to leave a little bit of material for a finish cut on the side, just like I did earlier. I'm leading it with a helical like we did earlier. When you do a helical cutter path, you tell it the radius as well as your in feet amount. So as you do 360 degrees of revolution, how far in you advance. Very similar to like a thread mill type of concept. Okay, so at this point, if I was to look at the program, I should get everything roughed out with a 3/4 inch tool. So rough around, it's going to come across. Again, roughing out. Rough. So we see that we roughed everything out with the 3/4 inch tool. So now we just have to do some residual material. So I guess in theory, I could just do one residual and let the 1/4 inch end mill do the whole entire vertical wall, or I could break this up into 2. I'll show you how to break it up into 2 just for the example's sake. So at this point, I would now need to load in my next tool, and I would do this tool change. I'll do this right here as its own tool change, independent tool change, just like we did earlier. So I would go and get my 1/4 inch tool, call up my appropriate cutting edge, D1, tell it an M6. Once it's done the tool change, I'm probably going to want to start up my spindle at some RPM. G94 is modal, but it's not a bad habit to get into. If I, for some reason, was starting in the middle and I didn't want to scan up to it, I can tell it right now. So we'll just say 50 inches per minute. Certainly it's G-code, so I could just do a rapid move of G0 right now, go to some location, but I don't need to do that. I can immediately go into some cycles. So what I want to do here is I'm going to need these 2 calls. So I can just cut and paste them. If you use your mark function, you can highlight multiple lines and then hit copy, bring it down, paste. So there is my call for my boss cycle. So in this case, when I go back to contour mill on the spigot, I'm going to go back to residual material, give it some default program name, some retract position. So we're going to say that I'm retracting to 2, safety distance 1 thou, feed, we'll say 50 inches per minute. And what is the tool that I used originally? And then what are the dimensions of the pocket? Accept it. So now we should be able to then go in and do my island residual material as well. So I'm going to copy these 2 events. Mark, highlight the 2, copy them, I'm going to put them down here. Now we're going to go into the residual material. So the only difference, the residual material here, is I do, and I don't have any Z clearance, I do need to have to tell it what tool. See, since I can break these sequence of events that I had to do in Shopmill, it does need to know what tool was used to rough this out. So that's all that this TR is telling me is, hey, when I go to figure out where there's material left, I need to know what tool had been used. So it doesn't do a tool change to this tool, right? It's still going to use everything. It's going to be done with the 1/4 inch tool. Now in this scenario, I did leave 10 thou on the wall, and I wanted to take a cleanup pass on the bottom, just like I did earlier. So I'm going to go back into my pocket cycle. What did I do here? Oh, that's good. Is this pocket? No, that's good. All right, sorry. So now we're going to go back to the pocket cycle. I do want to come down and tell it I'm doing a finish, and I'm doing a finish on my base, and I'm going to zero out the X and Y. Okay, now, at the end of a G-code program, there are some slight differences. A couple extra steps I normally would do. First, I probably want to clear my tool or get my tool away, maybe shut my spindle off, shut my coolant off. So if I was going to shut off my spindle, I would give it an M05 or an M5. If I had coolant running, I could give it an M9 to shut it off. To retract up out of the way, we have a command called SUPA. And what SUPA does, S-U-P-A, SUPA will, it's a non-modal command, and it will temporarily suspend all work coordinates active. So right now, I'm doing a D0 because SUPA won't suspend the tool offsets, and I do want to cancel my tool. And I'm going to tell it I want to be in a rapid mode. And I want to maybe tell Z to go all the way up to machine 0. This is assuming that the machine 0 on this machine is the top of its travel in Z. Maybe I want to stage my X and Y. So here I can just do a final G0. Maybe this is a 16-inch travel machine. So I'm going to say that, well, from machine 0, centering of the table is negative 30 inches, and Y0 would bring it all the way back. Okay, so now we should be able to simulate. Roughs it out. We'll zoom in a little bit. Coming around just like we saw before. Very good. And there we see it pick those couple out, and now it's just coming around and doing my finishing with that final tool. So the order's a little different, but certainly all the same power and capabilities there. This is a good example of where programGUIDE probably is even a little more flexible than Shopmill. Obviously, both certainly very capable functions. All right. So now what we're going to do is we'll jump back to the slideshow for a second here. Next, I was going to just kind of jump in and show you the difference between automatic mode, specifically between Shopmill and programGUIDE. A couple of different tools, how it would look, how I can, maybe bring in blocks, basic block mode in advanced in Shopmill to see the results where you don't necessarily need to do that in G-code. How do I start in the middle of a program? There's some differences there. And then once we do that, we can then go in and open up for some questions. So let me just jump on back to our final part. We're done with the print, so I'm just going to maximize the screen here. All right, so first things first, why don't we take a look at running the Shopmill program that we did earlier. So there's our Shopmill program. So when I'm editing the program, I do always want to make sure the highlight is in the first line of the part. And by simply hitting execute, it's automatically put me in the auto mode. So when I'm on auto, I can certainly hit cycle start right now, and the machine would start running this part. You could bring up a simultaneous record. If you wanted some graphics, I could put show path on. If I wanted to have my graphics up as it runs around. If I started it from the beginning, I could have had the solid on the whole time. Now, we'll come out of simultaneous record. Now, a lot of times when guys run Shopmill type programs, they don't feel like they have enough data as to understanding or knowing where they're potentially going next. So that's an area where it's nice to leverage what we call basic blocks. So by hitting this vertical soft key basic blocks, when I run the program, it's going to show you every resulting line of all these different cycles. Now, let's say for argument's sake, I want to start in the middle of a program. Well, when it comes to Shopmill, what you're going to do is you're going to use your blue arrows on the machine. We're going to move down to the event you want to start from. So let's say I wanted to start just from the spigot mill cycle. I don't want to do the outside contour. Then you're just going to go into block search and hit start search. That will automatically scan up to this point, load any modal commands that happened prior to this that should be active, and it's now simply asking me for cycle start. So if I bring up simultaneous record, hit cycle start, it's always a 2 cycle start hit whenever starting in the middle. So if you ever see this and you're not expecting to start in the middle, this is an indication to you, continue program with NC start, that you are starting in the middle. And then you'll see where it didn't profile, it immediately went in and did the rest of its process. Okay. Now the other way to start in the middle would have been if I was back in the edit mode and I had left my highlight sitting on an event other than the header. When you come to execute, it automatically says, well, you may want to start in the middle. If you don't, just hit reset. It'll rewind the program. Boom, back to the header. If you did, you could absolutely set OK, cycle start, and it would have started from that point. Now, the big thing I wanted to show you guys is really the difference in the way programGUIDE works when starting in the middle, because there are some core differences. And this would be your first chance to see that scenario. So when I open up the programGUIDE program, this still all looks the same. So certainly, where I leave the highlight could potentially stage where it's going to start. So I'm going to leave the highlight at the beginning of my program. One thing you'll notice I hadn't put in here is sequence numbers. We do have a function, if you hit the double arrow over, to adjust your vertical soft keys. Now this is when you're on edit mode, and you get a renumbering button. And this exists in Shopmill as well. You can put line numbers on Shopmill. So here, it will automatically insert line numbers. I usually always save that for last. There is also a function under settings if you want it to automatically put line numbers as you're going with the program. You can adjust it here. There's a whole bunch of different settings you can tweak to kind of customize the system to your wants or needs. So going back to auto mode, with the highlight on the first line, if I hit execute, it will bring me in. Certainly I could hit cycle start, and it would start running the program. If I started from the beginning and had simultaneous record on, I could certainly see the blank. So this all looks the same as I saw before. Now certainly basic blocks will work while I'm in a cycle, but not necessarily needed if I'm just running straight cheat code. The difference with block search, however, is you get a block search mode key now. And you can control whether you want the machine to do what we call smart start, which is start with calculation. And that's where it automatically in Shopmill will scan to the point you're starting from and then set up all any modal commands. Or you can do without calculations. So let's say, for argument's sake, you've got a very large program and you want to just start from a known good tool change. Well, here I could come down, move it all the way down, search down, or just arrow it down till I get to, in this case, I want to start from this tool change. So at that point, if I go to block search mode and I say without calculations, any modal commands that happen prior to this point, it's not going to know. So now it's just a matter of, of hitting start search. Once my mode is sitting on without calculation, cycle start again. We'll simply tool change the quarter wrench, continue on. If you wanted to do the search, you must, absolutely must, have it set to either with approach or without approach. Both of these will cause what we call calculations. It'll scan to that starting point. With approach, we'll try to even address kind of a lead-in move by looking at the couple lines leading up to the point you're starting at. Without approach is assuming that you're at least going to a safe position, maybe a Z slightly above the part or something, so we'll just vector down to that point. Both will scan up. Okay, so what I'm going to do now is we'll just jump back here to the PowerPoint. Oops, no, didn't want that. Okay, sorry guys. So at this point, what we'll do is we will open up the floor for any questions that may have arisen. I know we ran a little bit late, we're about 20 minutes over. Thanks for those of you that were able to hang out. And at this point, if you have any questions, and it doesn't have to necessarily pertain to the topics that we have been covering, so if you had a question on another topic, we can certainly open up the floor to discuss some of those. Please enter them via the Q&A panel, And then if you would like, I could even try to turn on your own microphone if you want to. So at this point, please, anybody that has a question, shoot them on in. Now, I'm not sure if I am looking at this wrong or not. To see if anybody. All right, here we go. So Ronald said, how do you mirror in G-code? Okay, so we have a specific mirror statement in G-code. I can see if I can bring up some information on that real quick. Trying to think of what I have handy. It's simply a mirror statement. Actually, you know what? We might be able to see that here in our help. So let me see if I can pull that up real fast. Okay. So this would be kind of how the instruction would read. Let me just minimize that screen right there. It should be full screen for you guys. All right, so Ronald, this would be the statement and how it would read. It's a mirror or an a-mirror statement, and then you're going to define the axis at which you're mirroring about and even a distance command. The difference between mirror and a-mirror is this would be a new frame or a new switch, so it would potentially cancel any other frames or switches like a transmit statement or a rot statement. An a-mirror is what's called an additive command, like an incremental command. So if you had trans, rots, any of that kind of stuff prior to this point in the program, it won't cancel them. It will, or if you wanted to do mirrors stacking upon each other, you would have to use an a-mirror statement. So the way I got to this portion, this description here in Sinutrain, I simply went to the help field and typed it in. If you have doc on CD, you can absolutely pull it up on doc on CD. We also have doc on web. All right. So any other questions, by all means, feel free to send them in. You know, it's funny, I'm not sure if I'm actually viewing the Q&A panel properly, because that came in just through the chat window. I got so many windows being shared right now. Okay, here's a question coming in. Is any of the things that we looked at today, are they standard or are they options within the control? What I will tell you is the residual material is an option. So it may or may not be part of the machine, you know, when you get it. It really is kind of dependent on the builder. As far as in the Siemens world, it would be a physical option. So, you know, when we were back and we were looking at these different cycles, the residual material for spigot and residual material for pocket are both options. So those two may or may not be there. If the option's not there, the buttons will just be blank. It'll be just gray like the one you're seeing here. So you wouldn't have either of those. All right. So let's see. What other questions do we have right now? You know, I apologize if anybody has questions that I'm not seeing here. Put them through the chat window, because I don't think the Q&A panel is popping up properly. In fact, I believe Danny's on the line. Danny, if you want to try putting a question in via the Q&A field, that would be helpful, because I don't seem to be getting them. All right. Yeah, see, Danny said he has been. I guess I'm running into a little technical issue on my Q&A panel. It's not showing up here. Let's see here. Well, anybody that may have entered one into the Q&A panel, if you see the chat window, if you could put them in there, that would be great. I'm going to try to figure out on my end why my Q&A panel is not up. All right. Well, one thing we can try here, just to give it a shot. This is a good point, actually brought up by Danny, a colleague of mine. He was just mentioning that another option is the 3D draw, and that is correct. So in simulation, we'll pop into it here real quick. This 3D button, this function right here, may or may not be there. That is a physical option. If it's not there, you will just have the top view, and you'll also have your front view, rear view, left or right side view. And again, that would be more builder dependent on whether or not they want to make the 3D view a standard function or an option. So that would be an option. And that holds true for both Shopmill and programGUIDE, because it is the same function here. And I do apologize for those of you that are probably entering stuff into the Q&A panel. For some reason it's not coming up. And certainly we can toggle our wireframe on or off simply by expanding our vertical soft keys and hitting the show path to disable that. Gives you a little bit of a cleaner image, so it's a little easier to see it. All right. Ben asked, is there a standard post for EAA programs from CAD/CAM systems? Really, the post is a translator from the CAD/CAM system. So each CAD/CAM company is going to have their own post because it's their own translator. I'm not finding currently any standard posts per se. Mastercam, for one, they're obviously a big player in the field. They currently don't have a standard Siemens post. We have been working with them to have them incorporate one in their system, but it hasn't been released as of yet. NXCAM, some of the higher-end systems, Esprit, they tend to seem to want to develop a post for every install. I have had pretty good success with actually all of those guys, but there is some dependency on them. What's nice about some of the other CAM systems is they at least use standard post libraries. Some of the other resellers, they leave the post development up to the reseller, so that can be a little tricky sometimes. So hopefully that answers your question, Ben. All right. Well, I would certainly love to leave this open for more, but I know we went at least a half an hour over, and I appreciate you guys hanging on. If anybody has any questions that I didn't get to, especially since I had a little bit of trouble with the Q&A panel here, by all means, feel free to reach out to me either via an email or give me a call, and we can obviously take any of those offline. Again, I appreciate everybody taking time out of their busy days to join me. Hopefully this was educational for everyone, and hopefully I'll see you in the not-so-distant future for the next one. All right, so we're going to stop sharing currently. I will end the recording, and I will send the recording out to everybody. Thanks very much, guys. I appreciate you joining in. All right, bye-bye.